Welcome to another episode of Mr. Avila Physics. Today we're going to be talking about projectiles. A projectile is an object that is moving through the air in two dimensions, vertical and horizontal. Right? Examples of projectiles are a golf ball, any ball that you throw, a baseball, a kickball, anything like that. So here we can see a bouncing ball, how it moves vertically and horizontal at the same time. So this is a projectile. Here we have a basketball, moves horizontally and vertically at the same time. So this is also a projectile. Now, the good thing about projectiles is that once the projectile leaves your hand or feet or surface or whatever it is, once the projectile is moving through the air, then the only thing affecting the motion of that projectile is gravity. And as such, it can behave, or it does behave, like a free-falling object, as long as we ignore air resistance, which we will in this course, right? So if you threw a ball, if you threw a pass, right, you kicked the ball, and there was no gravity, the ball would continue to rise at an angle forever. But because there's gravity, the ball eventually falls down, which is the same thing with free-falling objects. So the good thing about projectile is that when an object is projected through the air, once the object is in the air, then the acceleration of that object is the acceleration of gravity, which, as we know, it acts in a downwards direction with a magnitude of 9.8 meters per second squared. And for this course, we will ignore the effects of air resistance. So if we're gonna look closely at projectiles and we're gonna analyze projectiles, we have to look at the motions of, we have to look at the vertical and horizontal motions separately, okay? Let's start with the first example of projectiles, which is a horizontal projectile. A horizontal projectile is a projectile that leaves a surface completely horizontal, okay? So if we look at the vertical motion of the projectile, we'll see that since the object rolls completely horizontal, there is no vertical component of velocity. So the initial vertical velocity is 0. As soon as the object leaves the air, then it is affected by gravity. And what do we see? We see that it starts to accelerate downward, which means that as time goes on, the vertical component of velocity starts to get larger and larger and larger. Why? Because gravity is causing the acceleration of the projectile. Here on the left side, we see an object that is dropped from the same height. What do we notice about the object that was just dropped vertically and the projectile? What do we notice about its vertical motion? Look at the velocity vectors here. Vertically speaking, the projectile behaves exactly as a free-falling object. Now, if we look at the horizontal motion, then there is an initial velocity, bx0 or bix, right? Since the object left the surface completely horizontal, there is a horizontal component of velocity. But since gravity is a vertical acceleration, then there is no horizontal acceleration. So if it doesn't accelerate horizontally, then we notice how the horizontal motion or the horizontal velocity of the projectile, it's always the same magnitude. It doesn't change. Okay? So to recap, when we're looking at projectiles, we analyze its motion, the vertical motion, the horizontal motion separately. The vertical motion behaves like a free-falling object, which we covered in Unit 1. And the horizontal motion behaves like a non-accelerated object, which we also covered in Unit 1. Okay? Now, let's look at a more general type of projectiles, which is projectiles at an angle. So in this case, a projectile is launched with a certain initial velocity at a certain angle, right? Right here. So when we analyze these types of projectile, we analyze them the same way, right? We look at the vertical component, okay? And in the vertical component, we know that since the object is launched at an angle, there is a vertical velocity, which is this one, BIY. And how do we find BIY? Well, using trigonometry, we know that BIY is going to be equal to BI sine theta. Then, as soon as the projectile is launched, it is going to be affected by gravity, and it's going to behave like a free-falling object, which we can see here. Look at the vertical component of the velocity. It's decreasing until, at the highest point, the vertical velocity is 0. And then on the way down, it starts to increase, okay? So on the way up, the vertical component of velocity decreases, and on the way down, the vertical component of the velocity increases. Horizontally speaking, initially there is an initial velocity, right? Bix. How do we find Bix? How do we find this component right here? Well, we just learned that to find Bix, this is going to be equal to Bi cosine theta, right? And since gravity is a vertical acceleration, then horizontally speaking, it doesn't change. And notice how the horizontal velocity is constant all the time, okay? So when we're looking at this type of projectiles at an angle, a couple of things we have to remember, okay? So first things we have to remember is that as long as the launching point and the landing point are at the same height, the time it takes to go up is going to be the same time it takes to come down, okay? Another thing that we have to remember is that if the launching height and the landing height is the same, this horizontal displacement and this horizontal displacement are the same, okay? So the time it takes to go to the maximum height is the same time it takes to cover the half of the range. This whole distance right here, the maximum distance covered with the projectile is called the range. And this is the maximum height right here, okay? So just a couple of things here. All right, so things to keep in mind when analyzing projectiles. Be careful about the information given. Make sure that you're using the vertical quantities as vertical and not horizontal. Remember that at the highest point of the trajectory, only the vertical component of the velocity is 0, but the horizontal velocity is not 0. So there is a velocity at the highest point. Okay, the projectile doesn't stop. It stops rising, but it doesn't stop moving. Okay, so remember that. The time it takes for the projectile to move vertically is equal to the time it takes to move horizontally. What does that mean? This means that the time it takes for the projectile to go here is the same time it takes to cover this horizontal distance. The time it takes for the projectile to go down here is the same time it takes to cover this horizontal distance. Okay, something to keep in mind there. And also, okay, since we know that vertically speaking, the projectile behaves like a free-falling object, then we can use the kinematic equations that we already know. The same thing with the horizontal motion, okay? We can use the kinematic equations that we know only with acceleration equal to 0. All right, let's look at some examples. So Here we have that a movie stunt driver speeds horizontally off a 50-meter cliff. How fast must the motorcycle leave the cliff top to land on level ground below 90 meters from the base of the cliff where the cameras are? So what we have is we have a cliff, right? The motorcycle is going to leave this cliff with a horizontal velocity of v, okay? That we do not know. Okay, the cliff is 50 meters. And the motorcycle is going to land somewhere in here, 90 meters from the base of the cliff. Okay, so they're asking us to find this velocity right here. Now, we do not know much information. We know the height of the cliff, and we know the horizontal distance. That's probably enough. So let's look at the vertical motion of the projectile. So vertical motion, we know the displacement, right? Y is equal to negative 50. We know the initial velocity in y, which is 0. We know the acceleration, which is negative 9.8. And that's all we know, right? So with this information, we can find the final velocity or we can find the time. So let's try and find the time. Now, why do I want to find the time? Because horizontally speaking, right? Horizontally speaking, I know that there is no acceleration. Okay, so I know that v, I do not know v. I know that the acceleration is 0. And I know that the displacement is 90. But because the acceleration is 0, the kinematic equations simplify a lot, right? Essentially, we have this velocity. Distance is equal to velocity times time. That's all we have, because everything else kind of cancels out. So that means that velocity is equal to distance over time. Now, I already know the horizontal velocity. I just need to find the time, which is what I'm going to do here. So here I'm going to say y is equal to bit plus 1/2 at squared. The initial velocity is 0. So minus 50 is equal to 4.9 t squared minus 4.9 t squared, which means that the time is equal to, take out my calculator here, and my calculator is not working. There we go. So that means that we are going to have 50 divided by 4.9, okay, square root of that gives me, okay, so to the power of 0.5, so that gives me that the time is equal to 3.19 seconds, which means that the initial velocity is going to be equal to 90 divided by 3.19, which means that the initial velocity would be equal to 28.2 meters per second. There we go, right? So what did we do? We took the information that we know and we separated it between vertical and horizontal. Then we found the information that we needed using the vertical quantities and used them horizontally. All right, let's look at another example. So a football leaves the kicker foot at a height of 1 meter above the ground with an angle of 37 degrees and a velocity of 20 meters per second. Calculate the maximum height, the time of travel, and how far away it hits the ground. So they're asking us to find the maximum height right here, the total time, right? The total time when it hits the ground, and the distance to the ground, the range. Okay, so let's see what we can do. Okay, all right. So 1 meter above, 37 and 20. So this is 1 meter, 37 degrees, 20 meters per second, and projectile lands something like that. All right, so let's look at the vertical components here, at the vertical parts. So I know the initial velocity, Piy, is going to be equal to 20 sine 37, right? That's it, right? That's all I can find out right now. So, okay. All right. So sine 37 times 20, 12.04. So the vertical velocity is 12.04. So now, if I want to find the maximum height, if I want to find this, what do I know at this point? Well, at this point, I know that the vertical velocity is 0. And since I'm only looking at the vertical parts of the projectile, then I can use that fact. So that means that, okay, I'm gonna go ahead and say by squared is equal to Piy squared plus 2gy. So 0 is equal to 12.04 minus 2 times 9.8 times y. So minus 12.04 divided by minus 19.6 is equal to y. Y is equal to, divide this by 19.6, and I get, oh wait, squared. All right, so 12.04 squared divided by 19.6, that gives me 7.4 meters. But don't forget that this 7.4 meters is measured from this point. This is 7.4 meters, and this is 1 meter. So the maximum height, we need to add the plus 1, and this is 8.4 meters. All right, now B, the time that the ball is in the air. So I'm gonna go ahead and say y is equal to Pyt plus 1/2 at squared. Now, some of you will say, well, can't I just find the time to the maximum height and multiply it by 2? No, because if you find the time to the maximum height and multiply it by 2, you'll be here, not on the ground. So you'll be missing this 1 meter right here. So careful about that, okay? I chose this example precisely because of that. So don't fall in the temptation of just finding the time to the maximum height and multiply it by 2, because this is where you be. Time of maximum height times 2. You're not on the ground, you are 1 meter from the ground, okay? So that's why I'm going to go ahead with this formula right here, okay? This is going to be minus 1. It's going to be equal to 12.04 t minus 4.9 t squared. Now, when I solve this equation for time, okay, this is going to take a little bit here, okay? So when I solve this equation for time, this is going to be minus 1 equals 12.04x minus 4.9 x squared x. This is going to give me two answers, negative 0.08 and 2.54. Now obviously time cannot be negative, so the time that it was in the air is 2.54 seconds. So total time would be equal to 2.54 seconds. Now the last question is, what is the range of the projectile, right? So the maximum distance. So I know that because there is no acceleration, I know that x, so this is horizontal. So horizontally speaking, I know that x is equal to bixt. So I already know t, but I do not know bix, but I can find it. Bix is equal to bi cosine theta, so this is going to be equal to 20 cosine 37. This is going to be equal to, okay, cosine 37 times 20. It's going to be equal to 15.97. 15.97 meters per second. So now I know that x is going to be equal to 15.97 times time, 2.54. X is going to be equal to 40.6 meters. Pretty good kick. Pretty good kick. Okay. All right. So, okay. Thank you all for watching. I hope this clears up questions you have about projectiles and you understand projectile motion. Okay. Thank you for watching. Bye.